Welcome to today's webinar hosted by Armit, dedicated to technologies that are critical for unmanned systems, from communication to situational awareness. And now I'd like to give floor to Elsight, who will be presented by Nimrod. Blinder, Nimrod, floor is yours.
Thank you, Darius. Thank you very much. I see a lot of familiar faces here in the audience. So for the ones who don't know me, I'm Nimrod, VP Sales at Elsight, been in the company for the last 5 years. And today I will be talking about how Elsight unlocked the future of uncrewed systems. Most of you know Elsight as a leading provider for resilient C2 for long-range operations, mainly for UAV and drones. But I would like to talk today.
Well, you want to mute.
Can you hear me? Yeah. But I'd like to talk today also about a bit lesson learned from Europe and Israel from active conflict zones, as well as share a bit, of course, about our roadmap. But more than anything, share with you what we learned about the change of mindset and concept of operations around reliable C2. So a word about the company. Elsight is traded on the ASX in Australia, headquarters in Israel, where we have teams already in the US, UK, and Germany, where by the end of this year, we will also open a production line in all three regions. We are mostly known by our Halo device that was launched during COVID, that provides what we call absolute connection confidence, meaning from the regulation side, from commercial applications, provide the safety needed to allow beyond visual line of sight operations above populated areas, and from the military side, enable the mission completion or the continuity of the mission. To date, we deployed more than 10,000 Halo units, most of them, by the way, in the last 12 months alone. We accumulated more than 500,000 operational hours, integrated in 50 different aerial platforms, over more than 100 customers, both from the commercial side and from the military. And of course, to support this, so we meet the highest military standards, NDA compliant, and soon enough, as part of our Project GI under the DIU, where they sponsor us to be on the blue list, where we expect to be any day now. Let's talk a bit about the challenge. So KO Magic talked very nicely on the need for reliable connectivity. So I won't return things that already mentioned, but I would say that when you ask anyone in the industry, you know, what's causing the losing the line of sight or losing the tactical communication, they will say either range, line of sight, or electronic warfare. And I want to address the spectrum interferences, or even share a story through what we learned here in Israel. Everybody knows what happened on October 7th, and among so many other catastrophes also on the communication side, nothing really worked. What happened is that the entire IDF went down south using the same bands, same frequencies, to the point where it's told that the helicopter pilot talked to the troops on the ground over WhatsApp. This created a change of mindset, I would call it, within the IDF. If until then they were looking at civilian technology in general and public infrastructure like cellular is almost taboo, since then they understand they need to change and adapt. And we see it in action over the past 2 years in the war with Lebanon. They had a situational room for spectrum alone, determining which units can use which spectrum and when. But no one really understands, you know, the entire picture of losing communication, where it's not only the mission completion, but also safety, lethality, modularity. And when talking about using tactical solution, think of the pilot exposure due to RF signature exposure. So both the soldiers themselves, they need to be out of the open to maintain the line of sight, and also the drone itself has a strong RF signature, so is exposed for detection and interception. Putting all this in mind, the Department of War in the States understood the challenge and even gave it a name, calling it interoperability, meaning the need to manage the entire available spectrum and not to rely on a single source of technology. Because if we look across the world today of what is available, so we have three main technologies: point-to-point SDR, satellite, and cellular. All has its trades-off, pros and cons. Satellite, heavy, costly, poor latency, and weight. Line of sight, as long as you have it, it's amazing performance, but has the limitations of EW and line of sight, and cellular coverage and altitude. We found that no single technology can be sustainable enough for this type of changing operations. And everything that the Department of War declared with the interoperability is exactly what we did for several years before then, by providing a multi-link management tool that manages the entire available spectrum, meaning combining anything that the military unit is using, any type of point-to-point, any satellite, and integrating it together with our solution that combines also the cellular links and other type of communication methods to create this one logical layer to manage the entire available spectrum. This is the Halo device that some of you are already working with, but as you can see, it has the different LTE 5G modems that comes in different flavors and variety, both as an OEM to be integrated inside the platform or encapsulated in the box to support less weight sensitive applications like UGVs, USVs, and others. I have a short video that I would like to present that should provide a good overview of the device, and then we'll continue.
Mission-critical, unmanned systems like UAVs and UGVs must have continuous, beyond-visual line-of-sight connectivity. Legacy communications like point-to-point radios don't offer beyond the line of sight, are frequently jammed, and suffer from limited pilot control. Despite commercial drones' frequent use of a single or dual cellular links, these often fail in areas without adequate cellular coverage. Unmanned systems offer endless efficiencies and target precision in deliveries, inspections, public safety, and defense, and yet are all dependent on continuous connectivity for C2, telemetry, and video data. What's the secret to provide robust, resilient connectivity for your unmanned aerial or ground vehicles? Meet Halo by Elsight, a lightweight, palm-sized, military ruggedized platform that is compact, modular, and portable. Halo gives you the ability to operate many drones simultaneously from a remote location. Halo aggregates and bonds up to 4 LTE/5G carriers, plus RF and SATCOM links using packet-level traffic optimization. With this spectrum-aware technology, Halo eliminates single points of communication failure while maintaining exceptional security standards with AES-256 encryption across all paths. Halo's data dispersion uses a logic layer to automatically route data through the healthiest networks, providing connection confidence regardless of environmental or threat conditions. Halo's design delivers spectrum superiority to every mission, for every application, for every industry. Secured, field-proven logging more than 500,000 hours in flight, and resilient in the most difficult environments and even in electronic warfare.
Great. So what the Halo essentially does is it understands the degradation or congestion of all available links. So once needed, it presses harder on the gas pedal on the alternative links to maintain the needed bandwidth and the lowest latency, where essentially we take the different types of data, it can be C2, telemetry, video, create a VPN tunnel per data type, encrypt it, split it into packets, and send it to our cloud infrastructure that can be either AWS or Azure when talking about civilian applications, or full on-premise closed environment when talking about more sensitive military applications where all this data is being reordered, resequenced, and sent to the VPN client as if you had a very long imaginary cable from the drone to the operator. While this is not it, we are also able to dispatch the video to multiple locations, and by this change the entire concept of operations to remove the operator or the soldier from the field and do everything from the HQ. And I will talk about it in a minute. The Halo supports native MAVLink commands. That means that the integration both on the hardware level and on the software level, where we have fully documented API, is extremely simple. Normally, an integration to a platform takes in between half a day to a day and a half until you're fully operational with the Halo device. And this is where we find the modularity and the need for adaptivity in the market. What I want you to take from this slide is not necessarily the logos we're working with, but more the variety of use cases where we work from the drone as a first responders and public safety in general to more commercial applications like delivery and medical, and of course, military applications like ISR and other, both for drones and also UGVs and USVs. To maybe summarize the value of the Halo itself, again, with the ability to manage the entire available spectrum, besides the redundancy, the obvious redundancy, we also provide a higher bandwidth, rapid deployment, as you don't need any ground infrastructure, no single point of failure, and one type that fits all types of platforms. And when looking of what the Department of War and across NATO countries are determining today, they are said that they don't want 15 years of R&D with these huge companies, but they are looking for this solution which are already TRL-9 can be deployed tomorrow morning with extensive battlefield proven hours and scalable. And this is exactly how we designed our current offering as we are working with the DIU, not only through the existing capabilities, but also via the agility to adapt. I will give two quick examples. One is a customer of ours that needed video encoding, and we rapidly developed a software-based solution on the Halo itself to provide on-site video encoding. This unlocked their business and allowed them to reduce additional hardware. Second is the fact that we provide global SIM cards that can work anywhere for any side of the border. You can just imagine the impact that it brings to real situation operations. And everybody now talking about FPVs and the ability to work the future FPVs. If you look now at the drone dominance, so today, in order to perform an FPV operation, you need 3 soldiers. One who is doing managing or flying the drone itself, another who is managing the sensor, the payload, and a third who is keeping the team safety. By moving all of this concept of operations remotely, essentially you need just a single soldier to turn the device on, look for safety, and everything is being done remotely. This is the type of things that we are bringing today to the industry. In terms of security, so everything on the hardware level, both the bootloader and the kernel, and generally speaking, all the authentication of generation of keys is being held by the end user, as well as the end-to-end data encryption, the OpenVPN over OpenVPN AES-256. On top of this, if you put the standard LTE encryption and the way we split the data into packets, we support already today the highest or the most sensitive applications through military and commercial. An example of an architecture that one of our customers has, so he combined, in this case, it was a Starlink satellite together with a DTC Domo Tactical point-to-point, and he used the 4 slots for the SIM cards to use 2 civilian telecommunication, as well as 2 private military-grade private APN. And by this, he achieved full redundancy of basically almost any available technology today that allowed him complete the mission in the most contested environment existed. All that I've explained and shared comes also as a GUI or as a dashboard, what we call our AllSight cloud management, where the operator can see live all the devices, all the stats, location, manage all the operation, and of course, everything around the connectivity, where he can determine the strongest link in any given moment, and by this, determine if he want to optimize the data flow, if you want to lower the resolution or the video or any other around this. We also do the same with a heat map of an RF recording. Basically, the halo throughout the route understand the signal level and create a visualization that allows you, both from the regulator side, the safety needed to allow long-range operations, and from the operator side, understand to create a site survey and know where he should fly and decide if he wants maybe to change route. To summarize the impact that we bring, so on top of the obvious of providing resiliency and ability to work in contested environments, I feel that both Elsight and the industry doesn't really understand yet the change of the concept of operations. Think that we are using the same type of tactical technology since World War One, and now that once we are able to do all this operation remotely, think of how does it unlock and changes the concept of operations. And we bring it, of course, to exchange the mission range and to manage the entire fleet of drones or any other IoT devices from a single source. And in that way, expand many complementary services and enablement in the industry, such as the companies that will talk right after me. I would, before ending this session, I would like to talk about a feature or a product that is already running through via different customers of ours and will be fully productized in the next few weeks, which is a need that came from the market, from the battlefield, of GNSS-denied locations and how to overcome navigation for long-range operations. If we talk about 1,000 kilometers of drone operation, we're talking about 20 kilometers of drifting by wind, which makes inertial navigation or vision-based navigation extremely challenging. And what we developed over the past few months is the ability to do cellular-based navigation, basically by understanding the location of the cellular towers in the region, both by public databases and over AI capabilities where the Halo sniffs and understand the location of these cell towers as well as the distance. It's able to calculate the exact positioning of where he is in a very impressive radius of 150 meters. And by this, enhancing many other solutions, either existing navigation solutions, satellite solutions that need also this GPS, and more than anything for the operator, understand where he is and where the target is, and to the very end, to provide him a live tracker. What you can see here, the blue line is the actual GPS, and the dots are the cellular-based positioning that we get from the Halo device. So just before I wrap up, the last slide, what I want you to take from this presentation is that resilience connectivity is not an optional, it's a mission critical, and it's just scratching what's needed, the future battlefield in terms of automation. With this being said, I would strongly recommend to join another webinar we are doing in 3 weeks by our CTO, a 1-hour webinar of the vision of roadmap of Elsight. And check us on LinkedIn to see everything that we are doing with the DIU and SOCOM. And I think it gives a very good direction. Just as a last liner, I would say that if until a year ago we were working mainly with the OEMs to start and saying how we can unlock their business. Now we are working mainly with the end users, with the Army units, and with the DIU and SOCOM to set the demand and the criteria of what's needed to support a battlefield. And we are very much looking to collaborate with each and every one of you. And thank you for the time today.